Bismillahirrahmanirrahim. Welcome to the 9th lecture of Statistics and Probability Theory. In previous lecture, you have studied expected value and variance of discrete random variable continuous probability distribution. We have learned that how to find out the expected value and variance of discrete random variable. Let me remind you that we have two types of random variable, discrete random variable and continuous random variable. Discrete is the variable in which we can count, it is countable, whereas continuous is the random variable in which we can measure in a given interval or a certain interval. The expected value for the discrete random variable can be calculated by using expected value of x. Let's say x is the random variable is equal to summation x into p of x, whereas variance can be calculated as sigma square is equal to summation x square into p of x minus summation x into p of x whole square. This is the way to find out the expected value and variance of the discrete random variable. Then we have studied the continuous probability distribution, how to calculate the probability when the random variable is the continuous random variable. In the current lecture, we will gonna study cumulative distribution function of continuous random variable, expected value and variance of continuous random variable. Cumulative distribution function of continuous random variable. We can define it as the cumulative distribution function. Usually we denote it with capital F of x of a continuous random variable, capital X with a density function f of x. So basically the probability density function, you can say it p of x2, is capital F of x is equal to probability x less than equal to small x. The smallest x is basically the particular value till which you want to find out the probability is equal to minus infinity to x f of t dt. You are integrating the particular function for minus infinity less than x to infinity. This is basically the limit of your random variable. Your function is defined only on this limit, minus infinity to infinity. In discrete random variable case, where we have the discrete probability distribution function, you were finding out f of x by summing up all the probabilities till the particular point. And as you have noticed, the limit of the functions are written as x is equal to 0. Let's say it's starting from the 0, 1, 2, up to some particular point, or it could be till infinity, but the limit of the discrete probability distribution is always in this form, as discrete random variable is something which is countable. So we can't define it in the form of the interval, whereas the continuous probability distribution function is in the form of its limit is written always in the form of the interval. Example 1. Suppose that the error in the reaction temperature in centigrade for a controlled laboratory experiment is a continuous random variable x having the probability density function. This particular probability density function is defined here. F of x is equal to x squared by 3, where this particular function is defined on this limit minus 1 less than x less than 2. 0 elsewhere. Now what this function is saying? It is saying that this particular function is only defined on this limit minus 1 to 2. Whenever you substitute the value in this function other than this limit, for example, if you are substituting the value of x less than minus 1 or you are substituting the value 2 greater than 2, in both cases this function will give you answer 0. So this elsewhere means that outside this limit this function will give you 0 answer. This function will give you output only for this particular input. Find capital F of x. It means you have to find out the cumulative distribution function and use it to evaluate probability 0 less than x less than equal to 1. Let me tell you something here. In discrete case, if you are writing like this, let's suppose your random variable has the limit x, it should be small x, 0, 1, 2, let's suppose. Whereas you have some probability distribution function f of x in case of discrete. Here x is the discrete random variable. Okay, now you have to find out the probability x less than equal to 1. What you were doing there? You were simply adding the probability till the particular point 1. That is, probability x is equal to 0 plus probability x is equal to 1. But what if it was written here x less than 1? So what you gonna do? 1 will be not included here. It should be this. Because here we have x less than 1, not x less than equal to 1. In discrete case, this equal to sign matters. But in the case of the continuous, you write here less than equal to 1 or less than 1. It will give you the same interpretation. Like if we wrote right here x 0 is less than equal to x less than equal to 1. It seems same as this. Why? Because in continuous case, whether you write here equal to or not, it means the same meaning. It owns the same meaning. Like here, this minus 1 is less than equal to x or less than equal to 2, or you write it as minus 1 less than x less than 2, both have the same meaning. In this particular limit, minus 1 and 2 both are included in the limit. You can include here minus 1, you can also include here 2. Why is this happening? This is happening because this is the continuous case. in continuous case, what we do, we always find out the area between, whenever you integrate, what you are doing, you are finding out the area between 2 points. Like, let's suppose the curve of this particular function is like this, from -1 to 2. Let's suppose this is the curve of this particular function. What you are asking, if they are asking here, find out the probability between 0 and 1. What 0 should be somewhere here, and 1 should be here. So what does this mean? You are basically finding out, this is the probability density function. Area under this curve should be equal to 1, as this is probability density function. Whenever you are finding the probability 0, less than x or less than equal to x or less than equal to 1, you are basically finding the area between 2 points, 0 and 1. You are basically finding this. But in continuous case, you can't find probability x is equal to some particular point. Let's say in this PDF, you were asked to find out the probability x is equal to 1. You can't find out this. Why? Because whenever you integrate, you are basically finding out the area between the 2 points. Here we have only 1 point, probability x is equal to 1. So how can you find out the area? Let's say you integrate this function at x is equal to 1. That means you are finding out the area at the particular point 1. So the lower and upper limit should be equal to 1. So x square by 3 dx, if we integrate it, it will be equal to x raised to power 3 over 9, and the limits are from 1 to 1. What you gonna do? You will going to substitute the limit. First we enter the upper limit, which is 1 by 9, and then we will put here the lower limit, which is also 1, and it will be 1 by 9. So what will happen? Answer will be 0. And it is obvious that the area should be between 2 points. It can't be, we can't find out this area on this 1 point. There should be no area. It should be 0. So in the case of continuous probability distribution function or probability density function, you have to find out the area between 2 points. So whenever someone asks you that x is a continuous random variable and give me the probability or help me to find out the probability x is equal to k is some particular number, without going into the discussion, you simply say that it's 0, because the area between 2 points is, in integrating, we are finding out the area between the 2 points. How can we find out the area at the particular point? It should be 0. Now what we have to find? Capital F of x कैपिटल एफ ऑफ एक्स आपको फाइंड आउट करना है, आपने इंटीग्रेट करना है फंक्शन लोअर लिमिट से टू द पॉइंट x and the lower limit is -1. Here should be dx. You know the function is x raised to power 3, x raised to power 2. It is x raised to power 2 over 3 dx. So by integrating it, we will get this minus 1 till x. First, we will substitute the upper limit, which is x. It should be x raised to power 3 over 9 plus, and the lower limit, basically it is minus minus 1. We are now substituting the lower limit, raised to power 3 over 9, and it is equal to x raised to power 3 over 9 plus, because its power is 3, minus will be equal to plus 1 by 9. We can write it as x raised to power 3 plus 1 over 9. So this is basically the cumulative probability distribution function. ये आपका cumulative probability distribution function है. आपको कहा ये गया है कि इसको यूज करते हुए आप probability 0 less than x less than equal to 9 फाइंड आउट करें. एक बात जो पहले भी हम यहाँ डिफाइन कर रहे थे, फिर से अगर आपको मैं बता दूं कि कॉन्टिन्यूस के केस में यहाँ पे लेस देन हो या लेस देन इक्वल टू हो, दोनों केसेस में ये बात सेम है, बिकॉज कॉन्टिन्यूस में आपके पास ये चीज मैटर नहीं करती. हाँ, डिस्क्रीट में ये करती है आपके पास कि यहाँ पे लेस देन है या लेस देन नहीं है. अगर लेस देन इक्वल टू है, इक्वल टू का साइन है, तो आपने वो पर्टिकुलर नंबर उसमें इंक्लूड करना है. अगर इक्वल टू का साइन नहीं है तो आपको वो पर्टिकुलर नंबर इंक्लूड नहीं करना. लेकिन अगर कॉन्टिन्यूस है, जैसे कि ये कॉन्टिन्यूस रैंडम वेरिएबल है, यहाँ पे आपके पास इक्वल टू हो या इक्वल टू ना हो, -1 और 2 दोनों इंक्लूडेड हैं, ये बात आपकी अंडरस्टूड है. लेकिन अगर ये डिस्क्रीट का केस होता तो फिर -1 और 2 यहाँ पे इंक्लूडेड ना होते. ये आपके पास फर्क है डिस्क्रीट और कॉन्टिन्यूस के लिमिट्स में. प्लस एक बात जो अभी थोड़ी देर पहले भी डिफाइन की है कि जब भी आप कॉन्टिन्यूस से प्रोबेबिलिटी डिस्ट्रीब्यूशन फंक्शन में हैं, यानी कि आप प्रोबेबिलिटी डेंसिटी फंक्शन में हैं और आपको प्रोबेबिलिटी फाइंड आउट करनी है, तो प्रोबेबिलिटी हमेशा 2 पॉइंट्स के दरमियान फाइंड आउट होगी. बेसिकली आप एरिया फाइंड आउट कर रहे हैं और एरिया हमेशा 2 पॉइंट्स के दरमियान फाइंड आउट होगा. अगर आप कहेंगे probability x is equal to k, that is at some particular point continuous के केस में, तो वो हमेशा 0 होगा, क्योंकि एक पॉइंट पर एरिया 0 ही होगा. एरिया किसी 2 पॉइंट्स के दरमियान ही लाई करेगा. अब आपने ये फाइंड आउट करना है, तो आप अगर इस फंक्शन को यूज करें, आपके पास probability 0 is less than x less than 1, ये आपको फाइंड आउट करने को कहा गया है. अगर इसको कर्व को हम ड्रॉ करें तो आपके पास क्या चीज बनती है. लेट्स सपोज अगर ये इस तरह से ड्रॉ होता है, -1 से, ये सपोज कर रहे हैं हम -1 से 2 के दरमियान और आपने प्रोबेबिलिटी फाइंड आउट करनी है 0 से 1 की। सो आप ऐसा भी कर सकते हैं, व्हाट यू कैन डू, कि आपके पास 0 से लेके 1 आपके पास प्रोबेबिलिटी है, तो आप ऐसा भी कर सकते हैं कि आप 1 तक की क्यूमुलेटिव प्रोबेबिलिटी फाइंड आउट करें और उसमें से 0 तक की क्यूमुलेटिव प्रोबेबिलिटी माइनस कर दें। रेस्ट इज द प्रोबेबिलिटी बिटवीन 0 एंड 1। अगर मैं इसको लिखूं तो वी कैन राइट इट एज क्यूमुलेटिव distribution function, and we are substituting 1 because we are interested in the cumulative probability between -1 and 1। यहाँ इस x की जगह अब 1 आ जाएगा। ये x हमने इन जनरल लिखा हुआ था। अब जब हम यहाँ पे 1 सब्स्टिट्यूट कर देंगे तो इसका मतलब ये है कि -1 से 1 तक की जो क्यूमुलेटिव प्रोबेबिलिटी है वो आपने फाइंड आउट करनी है, माइनस f ऑफ 0। अब जब आप कहते हैं f ऑफ 1, इसका मतलब है -1 से 1 तक की प्रोबेबिलिटी, और जब आप कहते हैं f ऑफ 0, इट्स मीन -1 से 0 तक की प्रोबेबिलिटी। आपने -1 से 1 तक की प्रोबेबिलिटी में से -1 से 0 तक की प्रोबेबिलिटी को माइनस कर दिया है, तो पीछे आपके पास ये चीज बच गई है जो कि है प्रोबेबिलिटी बिटवीन 0 एंड 1। अब यहाँ पे आपके पास क्यूमुलेटिव डिस्ट्रीब्यूशन फंक्शन क्या हेल्प आउट करेगा, वो आपने ऑलरेडी कैलकुलेट किया हुआ है। सिंपली आप f ऑफ 1 कैलकुलेट करें, यानी कि आपने इनपुट देनी है, x की जगह वैल्यू सब्स्टिट्यूट करनी है 1, तो ये क्या आ जाएगा आपके पास 1 रेज़ टू पावर 3 प्लस 1 बाय 9 माइनस f ऑफ 0, यानी कि आपने यहाँ पे इनपुट वैल्यू क्या देनी है 0। आपके पास की क्यूमुलेटिव प्रोबेबिलिटी आ जाएगी टिल दी वैल्यू 0 रेज़ टू पावर 3 प्लस 1 ओवर 9। इट शुड बी इक्वल टू 2 by 9 माइनस 1 by 9, which is equal to 1 by 9। This is the one way to find out the probability between 2 points। आप इसको दूसरे तरीके से भी फाइंड आउट कर सकते थे। आप सिंपली अपने फंक्शन को 0 से 1 के दरमियान भी इंटीग्रेट कर सकते थे, आपके पास सेम आंसर आता। इसको अभी यहाँ पे फाइंड आउट करके भी हम देख लेते हैं। अगर हम इसे फाइंड आउट करें, 1 by 9 आपका आंसर आया हुआ है, वहां से आप इसको सिंपली अगर फाइंड आउट करते, अपने फंक्शन को इंटीग्रेट करते, अब फाइंड आउट करने जा रहे हैं प्रोबेबिलिटी बिटवीन 0 इज लेस देन x लेस देन 1। मैं फिर ये रिपीट कर दूं, ये लिखा हो या ऐसे लिखा हो, बात एक ही है, because you are in the continuous random variable case। So what you are doing, simply integrating the probability, going to find out the probability between 0 and 1, जो कि आपके पास आता है x raised to power 2 over 3 dx, जो कि आपके पास आएगा x raised to power 3 over 9, and the limit is between 0 and 1। अपर लिमिट आप पहले सब्स्टिट्यूट करेंगे, which is 1 by 9 प्लस फिर लोअर लिमिट सब्स्टिट्यूट करेंगे 0 by 9 which is equal to 1 by 9. So you are getting the same answer as you have got by using the cumulative distribution function. वो इसलिए किया था because the question is find capital F of x and use it to evaluate probability 0 less than x less than equal to 1. उसको use करना था. That's why वो उस तरीके से किया था. आप उसको इस तरीके से करें या इस तरह find करें. In both cases you will get the same answer. This is the solution. You can see this. Continuous cumulative distribution function. आप ग्राफ इस फंक्शन का इस तरह से बनता है. And this is the solution that we have already done.